I am Jay. I'm in charge of whole Europe. And this is?
My name is Mike. I'm the managing director or general manager of IDK Europe.
Right. Yeah.
Which is kind of hobby for me at the moment.
Right. We are going to explain who we are first, okay? Because I met some of you guys, and you said like, who's IDK? What do you do? Are you Japanese or Chinese? So let me tell you, IDK actually stands for Iwasaki Denki Gyokyo, meaning that Iwasaki is the surname of our founder, and Denki is electric industry. So it doesn't mean I don't know. Because in America, it's a big thing, like, oh, what is that? IDK? I don't know. But it means I do know, okay?
At least in the near future it will.
Yeah, exactly, exactly. And in Japan, we've been on the market for 30 years. And we are the leading company in Japan. However, we've been active in Europe. We founded our European office in 2015 or 16. And I've been in Europe at IDK nearly for 3 years now. Yeah. So this is who we are in Japan. We are located in Yamato, our headquarters, and in our German office, we are located in Düsseldorf area called Ratingen. And Mike is there and consulting you guys with all the technical support. And I'm normally on the road to meet you guys, okay? To the demo, presentation, and I always bring my IP-NINJAR demo gear.
So yeah, IDK has a distribution model. So this is now the world map of all our distribution channels. We actually started 5 years ago with Widelke Europe Limited, which is a German-based distributor, and actually it's me. That's why IDK is still a hobby for me. So IDK has been asking us to distribute their products for almost 7 years. And that time I found too much overlap with the products I had currently in product line. And but in the end, they convinced me to test at least some units from them, and that was exactly the moment when I said I need to have them on board, because it's been first time for a long time that you unpack a product and it's really plug and play and works perfectly. Has so many tools on it, and it's just no problem installation.
So it was like just plug and play without having to look at the manual, which was surprising for Mike. So okay, I will start distributing. And AED is our Benelux family in Benelux. So thank you so much for whole organization and setup that AED is distributing our IDK products. Yeah. And this is who we are. You see Hideki right next to me. That's the founder, and Ryuhei. And what we do in Europe, we do a lot of demos, presentation, this kind of holding of seminars. We have the logistic manager, whole accounting, and of course, Mike and the other German engineers. They're helping you to support some technical drawings and design, those kind of things, yeah?
Keeping stock and doing repair and service from Germany.
Yeah. Our key values, the most important thing is we are the no OEM manufacturer. So whenever you see IDK, that means that it is fully developed, designed, reviewed, and manufactured in our headquarters. We do have some OEM products, then we call them differently, NAPA. Okay? So when you see that NAPA, that means that that is OEM products. However, our Japanese engineers, they go through thoroughly what the spec says and what the products do. So our Japanese customers, they still prefer to use our OEM products rather than using the real manufacturer products. So that's the difference, right?
Yeah, this is our product lineup. First of all, of course, the IP-NINJAR. We are presenting more in depth later. Just a quick overview. That's basically where IDK started. It was a digital multi-switcher or presentation switcher. It's classical matrix with built-in scaling. And this is also all the features and tools we have on this switcher series is basically or was developed and implemented by customer feedback development. Then we have a modular matrix switcher with HDBaseT, HDMI, and optical front ends. Of course, extenders. The line ranges from HDBaseT over fiber and coax extender. So there we extend HDCP compliant HDMI 1.4 over a plain coax cable. Some small tools like switchers, distribution amplifiers, and multi-window processors.
Let me just give you one huge project. I mean, when I first started distributing, when I first joined IDK, we are nobody. Then Parliament found us, and they were interested in just simple DA, right? Then right after ISC, I visited them. I showed one simple switcher, which was 4x2. And that was the moment like, wow, this is a real pure manufacturer. They were impressed, and up to now, 20 mid-sized conference rooms have been successfully installed, up running more than two years, which is a huge story. That's why I'm so happy that our Parliament European institutes are here today. Yeah, we are going to talk about more case studies later, but let us move on to IP-NINJAR, which is why we are here. IP-NINJAR, that is the implementation of SDVoE.
Yeah, so with IP-NINJAR you have a very scalable and powerful platform. So it ranges from point-to-point extension between HDMI source and sink through network extension and switching, scaling, video wall processing, multi-viewing, and scan conversion.
And we have impressive lineup of IP-NINJAR. Every year, our IP-NINJAR family is growing. Okay, so we'll go through one by one what kind of different models we have. To start with, we call it O1 UHD. T stands for transmitter, R stands for receiver. So we have two different models. You see the first left, that is a fiber model. Okay, HDMI 2.0 comes out over one fiber, either single mode or multi-mode. Next one is the copper cable, copper version. That's why you see CAT. Yeah. We'll go through the details a bit later. And then the other models, we call it O4, transmitter TO4 HD. So if you see the rear side, you see there are 4 inputs of HDMI 1.4. And it's bundled as a HDMI 2.0 signal. So when you see it there, over there, so this is one of the multi-viewers, and then top right, that is the TO4, where we connected 4 different HD inputs. Okay? And we have the receiver that comes out over 4 HDMI 1.4. So you can connect it to 2x2 video wall directly.
The special, actually this receiver was developed especially for video walls. So it has a synchronization, so you can externally synchronize it to another clock. So all your screens in the video wall will stay in sync. And also, I don't know who of you knows the data path FX4. So if you need to go extension, you can, and you need kind of FX4, you can easily combine just a single channel transmitter with an O4 receiver, and you have all in one package. So you have the transmitter, the extension, and the FX4 basically, which splits your image for the video wall. You can even go other way around. When you have, let's say, a rendering cluster, and you do some ray tracing for photorealistic rendering, then usually a ray tracing's node can't provide 4K because it's very CPU intensive. So then you could choose a 4-channel transmitter which will combine the 4 channels into one image, go extension, and show it on a single 4K screen.
Yeah, clear? Yes. Mike, I'm going. No, I'm coming. I'm coming.
So the whole thing with what we've heard so far from SDVOE is interoperability. Can we take your 4K box and use it with your 4 HDMIs and you have one 4K input and have 4 quadrants of the 4?
Yes.
Okay, so it'll actually cut up the 4K signal and turn
Yes.
it to 4 individuals?
So in the 4-channel units, there is actually a second IDK-specific scaler or multiviewer, depends on transmitter or receiver, which is taken out of the MSD series, basically, and has all the same features. So for the SDVOE part of the transmission or reception of the signal, it sees just a 4K image, and we do the further processing on the outside.
Yeah, any questions? Okay. So just to make it clear, you can send one 4K source to RO4. Then you'll see that one 4K image on a 2x2 video wall, right? And you can send TO4 to one receiver 4K on a 4K monitor. Then it will be multi-view, 2x2 multi-view automatically, right? Clear.
Also, a customer feedback development is the SDI transmitter. So especially customers in the broadcast and rental staging area heavily requested us to have a SDI transmitter. So this is at the moment also still unique in the SDVOE world. So we are the first having the SDI transmitter.
Also the TO4, RO4, we are the only one, USP, unique selling points, we are the only one who have these kind of things, yeah? And moving on to next killer product, Dante Bridge. By the way, our Dante Bridge has won the Best of Show at Infocom. This is very new, yeah? We have the Dante Bridge that will receive up to 8 channels and send it to Dante network and vice versa. Yeah, I'm going to show you how it works. First, let's do this. This is a Dante bridge, right? We have the 10G port, which you can connect it to 10G IP switch, netgear, let's say, and you have a primary and secondary. You can send up to 8 channels of transmitters. So there are 3 different modes, 4 transmitters, 2 or 1. Send it to Dante network, vice versa. From Dante to receivers. Then you'll have audios on receiver side, sync devices. Okay? If you need more than 8 channels, you can connect second one. Third one, 24 channels, up to you. Okay? So up to now, you had to use the one dedicated receiver connected to Dante converter, which costs that much, nearly 1.5. Yeah? But now, you don't need all of this. You can just use our Dante bridge, send it to Dante, vice versa, from Dante to Ninja network. It is wow, right? Yeah, wow, wow. Yeah, I see that. I see the faces. It is a real wow. And we've already, so our parliament has got 1 unit. It will be installed in about 3 weeks. Yeah. So going back, so I'd like to move to preview first and then coming back to...
You can.
So we have the preview. Do you remember the thing? So this one, no, this preview, this is how it looks like. It's also, we are shipping it right now. It's a new product. It's like thumbnail preview. Rental staging guys, you guys wanted to see if the right source is coming and how it works. Yeah. So you can see up to 10 by 10 and 128 different layout, 10 by 10 configurations, and you can stream out to 8.264, which is another wow.
Yeah, it's a little bit independent of SDVoE. So it basically grabs the sources or the images through an HDMI input. So in the SDVoE world, you would have a dedicated receiver, and it's tightly integrated into the control system. So if you want to monitor several sources, the control box will automatically switch one by one, and the thumbnailer will grab an image. And you can have, as Jay said, the H.264 streams out of the thumbnailer. You can have an output showing your preview images, and there is an API available, so you can grab the thumbnails and put them onto your media control. So you have kind of live thumbnail of what's going on.
Okay, no questions? Right. So the other one is PDU, which is a power distribution. So you can connect up to 9 power supplies to PDU, power distribution. The main thing here is the last one, our control box. Is the beauty. It's the beauty of our IP-NINJAR. You wanted to do distribution and video wall, multi-viewer, whatever you want within this SDVoE. This is the key point, that this is our own API. As Charles said this morning, yeah, there is open API from the SDVoE. So on top of that, we developed our own API based on SDVoE API. That's why you're not going to get SDVoE open API, because it's only open to SDVoE members. And we have so many key features why we've won a lot of AV over IP projects, right? So we are going to show, Ninja Warrior. We'll come back to Ninja Warrior. Actually, I forgot to mention the Ninja Warrior. It's another beauty. Sorry. For you guys, actually, staging rental, right? You've been asking for this, Ninja Warrior. Ninja is already very powerful and invincible, but Warrior, wow. Right? It's in a ruggedized version. Mike is holding it.
We actually have them here. So it's a special version made for rental staging. So you can directly mount your clamps onto the chassis and put it into the rig. There is a hole for the safety, so there is no part which can be disconnected from the chassis, so it can drop in any case. So because the safety is going through the chassis, all the connectors are ruggedized Neutrik connectors, and typically what you use in the rental staging sector.
We'll put these over there on that table. Go and have a look and touch them, how beautiful they are, right? And we have another, which is, there is a chassis. So MediaTek from Sweden, they've developed a chassis for Netgear 8x8 IP switch. All the Neutrik connectors, 8 copper ports, 8 fiber ports. Go and have a look. They are waiting for your feedbacks and let me know, right? And then they are going to start production as of this September, once your feedbacks are well received, okay? So now we are going to talk about CTB. This is the whole overview of IP-NINJAR family. So in the middle, we have 10G Netgear IP switch, and all the different types of transmitters and receivers. Yeah, within our family member, IP-NINJAR family, no matter one you connect, our CTB, once you connect the CTB to 10G port, it will automatically recognize the number of different transmitters and receivers, up to 512 units. Wow, right? Yes, thank you. Thank you. So if you have a bigger than that configuration, let's go to Japan together for the big project. That's what we are going to do. We are going to grill our Japanese engineers, right? And we have CTB will automatically recognize the number of different transmitters and receivers. And do you remember what Laurent said? And it also has the 1G port, which you can connect it to 1G network for controlling, or however you like it.
Yeah, that's a special thing on our CTB or control box. We have actually two network connectors. One is dedicated for the video network, and one is dedicated for the control network. So you can cleanly separate the control from the video. So if your Crestron or whatever controller resides in the company's network, there's clean separation and you won't get any trouble with the IT.
So now, this is interesting thing. You always wanted to know, what are the codec, what are JPEG 2000, all the things. And our magic Mike, he's going to tell you and explain what kind of differences we have, okay?
Yeah, let's talk a little bit about codecs. So streaming is not new technology, but the way how it works, especially in SDV, is a really new development. So let's first have a look at established codecs, which are 10, 15 years old and which are good and good for streaming applications. There's two main types of codecs. The so-called intra-frame codec. It's basically a codec which takes each separate HDMI frame and encodes it and packs it into a streaming pipeline over the network. And the receiver will take the whole stream and recover the images and scale them into its own generated HDMI signal. There is no timing information, no nothing, which can recover the signal that once came into the encoder. So intra-frame codecs are, for example, JPEG 2000, motion JPEG, PNG image sequences, this is also used for recording or playback of video. That's very common in media servers. The advantages of intra-frame codecs are that the latency is kept low, but however the minimum latency you can achieve with such a codec is 2 frames, because there is visual formulas used to compress the video, which means the whole image must be into the system, in the encoder, to apply those mathematics, scale them down, compress them, and make them ready to go over the network. That means after the last pixel of an image, immediately follows the first pixel of the next image. So it's the first frame of latency we have already in the encoder. Then it usually takes some time to cut it into pieces, send it over the network, and the receiver needs also to have all the packets received to reconstruct the image. So that's basically the second frame you lose. So as we learned, the network doesn't really add additional latency, but the minimum latency we have here in this codec is 2. And because we want to keep the latency low, there is not so much time to apply a good algorithm. So usually the artifacts or the compression quality on intra-frame codecs are not as good as with other codecs, but latency is quite low.
So typically MVX, Crestron, they are using this JPEG 2000.
Yes. Where you need to know JPEG 2000 compared to motion JPEG in a low compression ratio, they are quite equal. So JPEG 2000 is more advanced when you do a heavy compression. But what is common to both, visual artifacts will will be recognized in a compression ratio of 6 by 1. And if you want to send a 4K 30 Hertz signal over a 1 gig line, you already need a 1 by 20 compression. So you will, of course, have to live with visual artifacts in this kind of codecs when you use just 1G links. Yes, other type of codec, very common codec, is the so-called interframe codec. Works a little bit different. Typical codecs are H.265, H.264. It builds kind of its so-called group of pictures, where in the beginning of each group there will be one so-called iframe, and the other following pictures, which is adjustable. The group of pictures can be adjusted in the encoder, and the decoder will automatically recognize how it was constructed. But basically there will be one frame, and the rest of this group will mathematically just describe how the image moves or changes over time. That means encoding side, you at least have a latency of the group of pictures. And decoding side, it's variable. The better the decoding should be, the more group of pictures you have to buffer to recalculate the visual image. Same here is no timing information is transmitted at all. So at the receiver side, you will always have a complete new signal. Advantage of the interframe codecs is that you can heavily compress and keep a really good quality. So if you have a very low internet connection with just 1, 2, 3, 4 megabit, you can still have really good results, but the latency will be very high.
Right. Then, what
questions?
Yeah.
Wait a second.
Okay. Give us something. What is it? Do you have any questions? No.
So, okay, now, how does SDVoE different? Any idea? Or too fast?
Sorry. Here we are.
So, okay, this is a so-called pixel pipeline codec. Yeah, basically it doesn't really wait for the whole frame to be in the encoder. It will just wait for a couple of lines of video and immediately packs these lines of video and sends them over the network. Yeah, the big question is HDMI 2.0 is 18 gigabit, and how do we just keep it at 9 gigabit and still tell you it's 1.4 to 1 compression? So when we have a look at the HDMI signal, it consists of 4 TMDS lanes. Transition minimized differential signaling. That's just the technical way to transmit this high bandwidth over the cable. And one of the lanes is for the red, one for the green, one for the blue, and one lane is for the clock, which is exactly using 25% of our whole bandwidth. And as we learned already today from Laurent and Charles, we don't really transmit the clock one by one. We just gather the timing, extract what it is, and send timing information into the network for the receiver. So the receiver can reconstruct one by one the same signal as it once was sent into the network. And the other thing is we just transmit visible pixels. Usually the HDMI frame is larger than the pixels you see. That's traditional from the old TV tubes, where also the audio resists. So it's usually in the blanking interval what you don't see. And we just omit this packet pixels and don't send them into the network. That's how we can achieve 1.4 by 1 compression at 9 gigabit.
Yes, yes, I'm coming.
Thank you. This morning you asked me why you didn't have a question about NDI yet, but at this point I can think of one thing that is working on NDI and not really working on the SDO VOE, alpha transmission. So
Alpha channel.
Alpha channel. So I was wondering, since any of the devices that are using a connector and a hardware-based input module, so not directly coming from a computer, it's going to be difficult to send the 4444 signal.
It's already very hard and difficult to use HDMI for alpha channel transmission because it's not defined.
Of course, it's not defined in an HDMI, but you could actually say that coming out of a network port, you can actually send the signal as video plus alpha nowadays.
You could. So if you have a special source which has a, let's say, second HDMI channel, and
yeah, you mean that you can actually send the video plus a Luma channel separately, but yeah, the thing is about using a combined 4444 signal, like if it's a data file, but that's not possible yet, right? Or it will not be possible in the future.
No, and it's not what it's meant for, because your source will always be HDMI or SDI or DisplayPort, and it's
since it's hardware based.
Yeah.
Any more questions? Yes, I'm coming.
You told that H.264 and JPEG 2000 codecs don't have any timing information, right? And the SDVOE does. So what would be the drawback then of the H.264 and JPEG 2000? In video wall, for instance, that they are not synchronized?
For example, video wall. So we will also show later a slide where we, so our platform has two different switching modes. So one is turning on our own scaler and losing basically the original timing. That's what you can. That's the only way you can do with the other codecs. And for video walls, for example, or if you do cluster rendering, where it really needs to stay in time, the other mode is the so-called standard or genlock mode. It really stays pixel by pixel in genlock.
Okay, great. Thank you.
So, any more questions? Okay, we are moving.
Okay,
on.
so so the summary is that the how we handle the video makes it possible to achieve this low compression at 9 gigabit, and to keep the latency really low. So to give numbers, it's between 7 and 23 lines of video, depending on the format and what other conversions you do.
Yeah.
Okay. Yeah, so here's the comparison between the so-called standard mode or genlock mode and the fast and scaling mode. So the names are
a bit different from
probably
SDVOE.
misleading. So fast, you would probably think it's faster than, or faster traveling than the standard mode, but actually in the fast and scaling mode we turn on the scaler. So that makes the switching between different sources faster, while the transmission in the standard mode is actually faster or has less latency. That's
Okay, I just wanted to say, I mean, a lot of customers are a bit confused. Why do they need standard? In standard switching mode, what's in is out. So this is the minimum latency. And we've won a lot of project for the conductor system because everyone has to play the same music note, or medical sector. You know, somebody's doing a surgery in a OR1, and it has to be exactly know where and when I'm cutting my liver, and then I'm telling the other doctor in the other room. So we are using, in this kind of application, we are using standard switching mode. It used to be called Genlock mode. In SDVOE, they are calling Genlock mode. We switch it to standard mode, the name. In fast scaling, we are just using scalar. And you can see that later, what kind of different resolutions you can do. Every type of resolution you want, right? Then I noticed that there is a full processing during Charles' presentation. Then there you can do the overlay, putting the channel number or what it is. Then you will see full processing, which is another upgrade. So in our O4 unit, you can already have overlay mode. So put the name on a monitor, sync devices, and source devices. But with O1 units, as of now, you'll be able to do overlay mode. Okay?
So this slide shows the difference when you switch between sources in the different modes. In the standard mode or the Genlock mode, when you switch between sources and the sources are different in resolution or timing, that means that your sync, the display, projector, whatever, will completely lose the signal as you do with a classic baseband switcher. So it really depends on the display or your sync how fast you see the next image again. In the fast and scaling mode, there's again two differences. Basically, or the first thing to notice, we turn on a scaler in the receiver, which adds latency of maximum 2 frames. But then you can seamlessly switch between different sources, which is truly seamless for same resolution, same timing. And in worst case, it's a 1 black frame, or if the resolution is also different, up to 12 black frames when you switch to another source.
Yeah, I'm coming.
Can you explain what the top switch is again? Is that, you said it's about 8 frozen frames, so it's not switching from one source to another in one frame, it's freezing? That's what the slide says. I wasn't sure if that's what you described. So it should just be a clean switch from one to the other? Okay.
Exactly. Yeah. That's how it should be. Yep. Right? And in standard switching mode, we disconnect between the receiver and sync devices. So it's all depending on your monitor behavior. Okay? What's in is out. Because sometimes people are like, oh. So this is what I explained, different applications. So it's up to you. And full processing is coming where you can do overlay. Okay? So already moving on, because you look so serious, I'm going to give you something interesting, okay, about the case studies and projects. Okay. Before we start talking about this impressive Yale University, I want to let you know what kind of European project we have, yeah? Starting with Parliament. Yes, this is amazing. So Parliament has been testing IP-NINJAR over 1 year already. I'm sure that he can, so our Arnold can tell you about beauties of CTV, all the things. But it's been proven that we are going to start the first room installation as of, let's say, as of mid of July, which is a big thing as a government. Normally government is a quite conservative party, but Arnold has been such a fan of this SDVOE, AV over IP. Let's start with AV over IP. Then Arnold has got to know our SDVOE solution, Netgear, all the things. And thanks to Parliament, we have another big project from the European Parliament, which will be 90 by 70 for the whole building. And it will start this November, 90 by 70. Huge installation in Helsinki. And we have Deutsche Telekom, 200 by 200 in Germany.
Not yet ready, but on the way.
So tell us about application. What kind of thing it is?
It's called the T Gallery. It's located in Bonn, and it's a presentation center where they present different technologies for different markets, for medical, transportation, home. And it's basically a 360-degree round building, and there is one continuous projection on the outside of the wall, and you can walk through this installation and through the different segments, medical, transportation, as I said, and all the projection on the outside wall and all the rendering from the rendering cluster, which is 218 nodes of sources, and it's 86 projectors and other displays. You will run through this installation and you get a personalized mobile phone, and you can interactively change the part of the application where you are.
And in Finland, we have a number of conductor systems in a theater and opera house. The reason why they've chosen is that our IP-NINJAR SDVoE solution delivers a minimum latency. When a conductor plays, everyone has to play the same music note. And they've got specific models that is hooked up with our NINJAR transmitters and receivers. And they are doing it as a bundling package going all over Europe. So which is another. Okay, then let me move to our wow, impressive case study. This is amazing. So let me tell you this. We've done 2 different buildings, and they are interconnected together over dark fiber. We started in 2017, a bit more than 2 years ago. And the first building was a sterile building, and it was 36 by 36. The reason why they've invested AV over IP was that they are not allowed to change anything. They are not allowed to renovate the building because it's historical. And hiring a professor costs a lot of money. So instead of hiring one professor, they've invested into AV over IP. How simple is that, right? It's advanced technology. So in 2017, we did sterile building. In 2018, summer, we did a baker building. So this is a footprint. So when lecture is happening in 127, and it's being distributed to other rooms, so that other students can see, watch what's going on, right? And this is how far it is from one building to next, and they are interconnected. Unfortunately, in this project, Netgear wasn't installed. It was the different IP switch. Okay.
And we had a lot of headaches with it.
Yeah.
So now everyone guess which switch manufacturer it was.
Yeah. Just to show you, this is the technical room. You see our beautiful NINJAR boxes, yeah? And before, when technical issue happened, a technician had to go to the campus, which took a lot of time, and everyone was interrupted and annoyed. What he does now, that he can monitor. He does the monitoring and 24/7, and he can do the troubleshooting, fix it, repair it at once. That's the beauty of this AV over IP, SDVoE, IP-NINJAR system. So everyone is happy, technician is happy, he doesn't have to move around, students are happy, right? So I'm going to show you the one room installation. So you see the PTZ camera, right? And back then we didn't have a Dante bridge, so they dedicated one receiver connecting to Dante converter. And where the professor is, so there are projectors, so that students, they can watch the lecture, and where the professor is, he also has the monitor, and seeing multi-view of different rooms. So when a student has a question, he just turns on the microphone and interactively communicates and answer all the questions that students have. So it is a real advanced technology. Advanced technology, and the other students do not feel left out because they can also ask questions and get the answers. The simple diagram it was like this, but it will be changing because we have Dante Bridge. They can save a lot of money now. Yeah? Our CTB, as we said, it has 2 ports, 10G port and 1G port. 10G port has been dedicated to 4K video audio, and 1G is dedicated to 1G IP switch connecting all the possible 1G products. So our CTB is a bridge between 10G and 1G. 1G can go through 10G, however 10G can never go to 1G network, which we learned today, right? We know about it, right? So now I'm going to show you how we did an evaluation. And for this 128 by 76 we did last year. So we did a thorough evaluation for our Yale University project. Once we are given this kind of project, we always make sure that this works. And this was our headquarters, 128 by 128, showing different switching modes, standard switching mode and fast scaling. And that was December in 2017. You can imagine how warm the room was, yeah, in winter. We loved it, 24/7, 3 weeks. And now it's been working for over 2 years. Let me tell you, over 200 endpoints. There is no zero failure point. And as a pure Japanese manufacturer, our strength is that we listen carefully what you're asking for. We never promise anything at the beginning, right? We just listen carefully and we try to modify however you wish. But we always play everything by the book, which is also important. Yeah? We are going to stop here. Thank you so much for your time and all the patience. And I see your look. Yeah, I'm happy. We are happy too.